Okay, let's use something we've already learned to deal with something new. So let's look at this really easy problem, 4 times 3. I know you know 4 times 3 is 12, but let's talk about why, what this means. This means 4 threes. So this actually means 3 plus 3 plus 3 plus 3. Again, multiplication is repeated addition. Okay, but if 4 times 3 is 3 plus 3 plus 3 plus 3, or 12, then we also know the answer to 3 times 4. And of course, I know you knew that was 12, but I'm trying to explain that we know that this has to be equal because of a property we've previously done called the commutative property of multiplication. So because of the commutative property of multiplication, we know 4 times 3 is equal to 3 times 4. Okay, so if that's so, what do you think the answer would be to 4 times negative 3? 4 times negative 3 would mean, again, multiplication is repeated addition, would be negative 3 plus negative 3 plus negative 3 plus negative 3. I hope I said 4 of them. All right. Well, now we know how to do this, okay, because we just learned how to add integers. When you do any operation, you always do 2 numbers at a time. Okay, so I owe you 3. I owe you 3 is I owe you 6. I'm writing this all down. I know you probably won't. I'm just doing this. I owe you 6. I owe you 3, so I owe you 9. I owe you 9, and I owe you 3, so I owe you 12. So we know that 4 times negative 3 is negative 12. We just showed you that. Well, what else do we know? Well, from the commutative property, we know that negative 3 times 4 is negative 12. Okay, so let's just summarize for 1 second what we've already done. So that takes what we know. So far we're good. That takes what we know. Now, let's take a look at this next thing. But let me summarize this. 4 times negative 3 is negative 12 is what we just did. Okay, here's the dilemma. The dilemma we're having right now is I know then that a positive times a positive is a positive times a negative, or a negative times a positive is a negative. The only combination I don't know yet is a negative times a negative. A negative times a negative is really kind of hard to think about, because if you have a negative times a negative, I can't really, what does that mean? Negative 1 not 5 times? I mean, I don't know what that means. So what you have to understand is math is about patterns. So I want to just show you something that may help us do that, evaluate that problem a little better. Okay? So watch. Remember, math's all about patterns. So I'm going to start by doing this. Negative 5 times 3, negative 5 times 2, negative 5 times 1, negative 5 times 0. I know, I'm coming. Negative 5 times negative 1. That's what we wanted to know. But, you know, hey, I like to go further than that. Okay. Well, we showed you in this problem that a negative times a positive is a negative. So we know this is going to be negative. And we just go 5 times 3, just like we did here, 3 times 4. We're just going to go 5 times 3 is 15. Well, a negative times a positive is a negative. 5 times 2 is 10. A negative times a positive is a negative. 5 times 1 is 5. A negative, oh, that's 0. Anything times 0 is 0. Now, I want to show you that there's a pattern going on here. That's the whole point of this. The pattern is that I'm going up by 5. I owe 15, but I have 5, so I owe you 10. I owe you 10, but I have 5, so I owe you 5. I owe you 5, but I have 5, so I owe you 0. So we're just going up by 5 all the time. Well, if we go up by 5 all the time, right, that means that 0 plus 5 is 5. And 5 plus 5 is 10. So here's what I know. I now know that a negative 5 times a negative 1 is 5. Negative 5 times negative 2 is 10. So now I know that a negative times a negative is a positive number. Okay, so here's what we know. We know that a positive times a positive is a positive. A negative times a negative is a positive. So when the signs are the same, the product is positive. When the signs are different, the answer is negative. So that's what we know, and that's in your book. Okay. So don't think money for multiplication. Money is only so far for addition. Maybe for something else, but we haven't seen that yet. With multiplication, you're just going to multiply as usual, and if the signs are the same, it's positive. Signs are different, it's negative. So let's look at the following problems. You're going to evaluate these, or just multiply. This should be an easy one. Okay. Remember, go 2 signs at a time. Go 2 numbers at a time. 2 numbers at a time. Okay. So the first one, I look at my signs. We're multiplying. The signs are the same. In multiplication, when the signs are the same, the answer is positive. 8 times 3 is 24. Multiplication signs are different, so the answer is negative. 10 times 2 is 20. I really like taking care of the sign first because I want to be sign conscious because everybody throws out the signs. Well, this is easy, 18. But it still follows the rule because signs are the same, positive. So it's positive 18. Okay. Now we're going to do these 2 first. Doesn't matter. Remember, more than 2 factors, it doesn't matter what 2 you do first. I'm going to just go left to right. A negative times a positive is a negative because the signs are different. 3 times 6 is 18. Now we have 18 times this negative 2. Well, now the signs are the same. The signs are the same, so my answer is positive. 18 times 2 is 36. Okay, so that takes care of multiplication. Okay, when the signs are the same, it's positive. Signs are different, it's negative. All right? Well, if that takes care of multiplication, what about division? All right, and I want to do division because, remember, division is the reverse of multiplication. Okay, so let's take a look, and this is in your workbook as well. Let's take a look at this first problem that's done for you. You already knew this problem, that's why I did this one for you. Actually, I didn't call this 1, I just called this an example. 10 divided by 2 is 5. And that's because our check, remember, says 5 times 2 is 10. Right? And that's, we've done that before. I want to do something and go backwards a little bit. We haven't talked about division of sign numbers, but what we do know is that whatever is here, if I do the check, this times negative 2 has to give me 10. So I can learn about my signs for the division, understanding what I know about multiplication. Okay? I know here my sign, to be a positive 10, I know my sign has to match. They have to be the same. So if this is a negative, then this has to be a negative. And obviously it has to be 5 because 5 times 2 is 10. So the answer here is negative 5. That means this is negative 5. That's how I can get that. So that's number 1. Try 2 and 3. See if you can get what the question mark asked you for. Okay, let's see how you did. Well, remember the check here. The check is going to be that whatever you put in that square times your 2 has to be negative 10. Well, obviously the number is going to be 5 because 5 times 2 is 10. But to get a negative, the signs have to be different. So if this is a positive, this has got to be a negative. So this answer here is negative 5 as well. Okay, so let's look at this next one. And this next one, the check tells me that whatever's in the square times this negative 2 has to be negative 10. This times this is this. Okay, well, I need the answer to be, I need the product to be a negative. The only way the product can be a negative is if these signs are different. Since this is already negative, this has to be positive. So this has to be, let me make them all the same color, just before, because I'll go a little crazy if I don't. Let me fix that. Okay. So this has to be a positive 5. Okay, not a 0.5. Okay, so this has to be 5. So let's think about what we now know. Here's an example where the signs are the same and we're dividing. The answer is positive. Signs are the same and we're dividing. Answer is positive. Signs are different. Answer is negative. Signs are different. Answer is negative. That's the same rule for multiplication. So multiplication or division, Okay? You either multiply or divide, depending on what the symbol tells me. So it's not, you're not thinking money. Either multiply or divide. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. Okay, so that's pretty simple. Okay, but remember that only works for multiplication and division. Okay, let's take a look at a couple problems. Okay, so number 1. Number 2. Okay, so let's take a look at this first one. In this first example, positive 4 times negative 2. Now we're multiplying. Signs are different here, so the answer is negative. Signs are different here, so the answer is negative. 8 times 1 is 8. So the answer there is negative 8. Or if you just realized that positive times a negative is a negative, 4 times 2 is 8, and then multiplying by 1, remember the multiplication property of 1, you have to get back where you started. So you get negative 8. Okay, be careful here. This is addition. Now we have to think money again. So think of having and owing money and paying your bills. Okay, I owe you $14, but I have 2. That means I owe you $12 divided by 6. The signs are different here, so the answer is going to be negative. 12 divided by 6 is 2, and you're done. Okay, let's look at number 3. Number 3 says negative 3 times negative 10 times negative 1 all over negative 2 times 5. Okay, that's a good one. All right, I'm going to do, like I did yesterday, top and bottom. So I'm going to do the top first. Okay, for the top, I have negative 3 times negative 10 times negative 1. So don't do all 3 and think all the signs are the same, so the answer is positive. You got to do 2 at a time, okay? Negative 3 times negative 10 is positive 30, because the signs are the same. 3 times 10 is 30, times negative 1. Positive times a negative. Signs are different, so it's negative. 30 times 1 is 30. So notice what you would have done. You would have made a mistake if you just said all the signs are the same, so it's positive. That rule works for only 2 at a time, so be very careful with that. Okay, so the top is negative 30. Okay, let's do the bottom. Well, the bottom I can do right here. Negative 2 times 5. Negative 2 times 5, the signs are different, so the answer is negative. 2 times 5 is 10. But now you're dividing in division. The signs are the same, so it's positive. 30 divided by 10 is 3, so the answer is positive 3. So now if you want to try 4, 5, 6, and 7, and then we'll come back and check your answers. Okay, let's see how you did. Number 4, we're multiplying by 0, so the answer is just 0. Okay. Number 5, signs are different in multiplication, so it's negative. 1 times 6 is 6. In number 6, 2 at a time, remember, be careful. Okay. Negative 3 times negative 1, signs are the same, so it's positive. 3 times 1 is 3. 2 at a time, well, that's obviously 6, or positive times a positive is a positive. Signs are different, so the answer is negative. 6 times 5 is 30, so the answer is negative 30. So that takes care of 4, 5, and 6. Let's look at the last one, number 7. Number 7 had lots of factors in it. Let's see how that worked out. Negative 3 times negative 1 times 2 times negative 5 times negative 4. Wow. Okay. And then, again, don't think I see a different sign, so the answer is going to be negative, because we have to do 2 at a time. Signs are the same. It's going to be positive, positive, times 2, times negative 5, times negative 4. Okay, signs are the same, so it's positive. Okay, signs are different here, so it's negative. Signs are the same here, so it's positive. And 30 times 4 is 120. That takes care of the 7 of them. Hope that worked out. Now, let's talk about a little shortcut, okay? If there's an odd number of negatives, then your answer is going to be negative. If there's an even number of negatives, then your answer is going to be positive. Let me show you. Okay, in this problem, there are 1, 2, 3, 4 negatives. That's an even amount. That told me my answer was going to be positive. So if there's an odd number, it's going to be negative. If there's an even number, it's going to be positive. And that's true in multiplication and in division, because it's the same rule. Okay, so let's look at a couple of problems. Okay, these two are like my favorite ones because you know what? I saw many teachers get these wrong. So let's deal with these next two. I'm going to let you try them because you know what? Truthfully, I want to get you. So you try these two, and then we'll look at them. Okay, so here's the deal. See this 2 and this 2, the exponents, they look like the same problem, but they're totally different. An exponent only works on what's to its immediate left. So again, if this 2 falls down, it falls directly on the parentheses. That means the entire parentheses is the base. So that means both the negative and the 3, the entire negative 3 is being squared. So it's a negative 3 times a negative 3, which is a positive 9 because the signs are the same and we just multiply. This question is completely different. In this question, if the 2 falls, it only falls on the 3. So the only thing being squared, the base here is 3. The base here was negative 3. The only thing being squared is the 3. The negative just comes down. It's just like saying the opposite of 3 squared. Okay? So this is going to be a negative 9. They're completely different, and most people really have a problem with that. Okay? They are different problems. Okay, last set of problems to show you this little exponent rule about even and odd and all that stuff. Let's take a look at this. Answer true or false. I'm going to let you do this for a second, and then we'll answer it. Okay, without even doing this problem, I see that a negative raised to an odd power is going to give me a negative. Now, here, the 1 is being raised to the odd power, not the negative, but the negative is going to come down, so it's still going to give me a negative. But now the issue is, are these going to give me the same answer? So I'm just going to work it out. Negative 1 to the 33rd power, it's definitely going to be negative because it's odd, but it's going to be 1 because 1 times 1 times 1 times 1, 33 times is still 1. Here, you do it different because the negative just drops. But again, 1 times 1 times 1 times 1 times 1 is still 1. So even though you do it different, because of the nature of this problem, this is a true statement. Okay? Let's take a look at this one. In this problem, this is the one we saw before a little bit. The base is not negative 5. It's only 5. So the only thing being squared here is the 5. This actually becomes negative 25. Here, the entire parentheses is being squared, so it's negative 5 times negative 5, which is positive 25. So this is actually false. Be careful about that. Okay. And because you have to be careful about this, this brings us to our next problem, which is evaluate this expression for x being a negative number. Now you're going to see the beauty of those parentheses. Okay, why you absolutely have to use those parentheses. So let me show you. In number 1, we get x squared. Number 2, we have negative x squared. And we're asked to evaluate both of these when x is negative 7. Here's what you have to remember. We said when we substitute, we want to put the number in parentheses because we're squaring the x. And what's the x? The x is negative 7. The entire x is being squared. So this is negative 7 squared, quantity squared, which is negative 7. Well, I don't want to write the work there. I think I can do that one in my head anyway. But it's negative 7 times negative 7, which is positive 49. Where this one, by the way, you should know this answer right away. We already did x squared, and this is truly just saying the opposite of x squared. So the answer should come out to be a negative 49. But let's look at it together. Again, I have to do exponents here. This negative comes down. Negative 7 squared, because that's what I'm doing. The whole thing is being squared, and we get 49. So our answer is negative 49. Let me tell you how people usually get this problem wrong. Okay, this is really important. People will usually take this question and go like this. This is wrong, wrong. negative 7 squared. Because if you don't have the parentheses on them, then the answer you should get is negative 49. Now, some of you do it wrong, and then you still get the right answer because you did it wrong twice. Okay, so you made a double error. Guess what? I marked that wrong because the whole way you did it was incorrect. There's absolutely, you're squaring the entire x. Squaring the x is the entire negative 7. So it's very important to use parentheses, and that's why I made you do it for the problems that you really didn't need to do them for, but you absolutely need to use parentheses here. So I'm just going to use parentheses anytime we substitute. All right, that's how to multiply and divide integers. Now, next time we're going to do subtraction of integers.